This is practice A for section 7.4. We're looking at the back of the worksheet. We're going to find the value of each variable. We're going to write our answers in simplest radical form. This shouldn't take a lot of time. There's not a lot of calculation to be done here. This is a right triangle. You have two congruent acute angles. That means this is a 45, 45, 90 triangle. So your legs are the same. If this leg is 10, this leg is 10, your hypotenuse is 10 times the square root of 2. Notice how we only know two angles in this, number 16. We can calculate the other one. It's a 30, 60, 90. So the short leg is 12. The hypotenuse then is 24, and your long leg is 12 square root of 3. Number 17, 30, 60, 90 triangle. If your hypotenuse is 16, your short leg is 8, and your long leg is 8 square root of 3. We really should be able to move this quickly through these problems. No calculation. Number 18, it's a 45, 45, 90 triangle. Your hypotenuse is 15. What would your legs be? Well, we need to divide by the square root of 2. So this is where you might need to do a little bit of calculating. I know it's just going to look like this, 15 square root of 2 over 2, because I've done this type of problem lots before. Because this is odd, these don't reduce, this 15 halves. If this was even, like 16, then you'd have 16 over 2, which gives you 8 times the square root of 2. So the idea is, whatever this is, you take half of it and then multiply by the square root of 2. Since there isn't really a half of 15, 7.5 you could put, but on a multiple choice standardized test, you're going to see this. 30, 60, 90 triangle. Long leg. Short leg. Hypotenuse. This is your long leg. This is your short leg. Again, this is going to involve a little bit of work if you haven't done this before. You need to rationalize the denominator. You need to divide this by the square root of 3. So what does that look like? Well, it looks like 5 square roots of 3 divided by 3. If this was 6, 6 divided by 3 would give you 2 square roots of 3. So when you divide by the square root of 3, you're really dividing this number by 3 and putting a radical 3 on there. So that's your short leg. Your hypotenuse then would be 2 times this. And you might not be sure what 2 times this is. If you're multiplying by 2, that's 2 over 1. So the 2 goes in the numerator. So it's going to be 10 square roots of 3 over 3. Number 21. In the diagrams to the right, which side length is the longest? Okay, well, they don't tell you any lengths here. But we know that A and B are the same. We know that C is definitely bigger than A and B because it's the hypotenuse. So A and B make no sense. If we would just pretend for a second that this is a number, maybe this is 5, then this would be 5 square root of 2. Well, if this is 5, because notice how these match, then this hypotenuse, that's E, would be twice as big. This long leg would be 5 times the square root of 3. So where your hypotenuse over here was 5 square roots of 2, your long leg over here is 5 square root of 3. Square root of 3 is bigger than the square root of 2. So that long leg must be bigger than this hypotenuse, regardless of what the values of those A and B are. Number 22, you have some bleachers. 30, 60, 90 triangle, I think. Yeah, I guess you're assuming this is a right angle. It doesn't really say that there. But I guess if these are bleachers, these are probably pushed against a wall. That's probably a right angle, most likely. Otherwise, you can't do the problem. If it's a 30, 60, 90 triangle and you know the hypotenuse, then you know that this short leg is half of that. So how high above the ground would those seats be? 12 feet. Number 23 is about baseball. The baselines of a baseball field form a square. The distance from home plate to first base is 90 feet. Use the diagram at the right. Round your decimal answers to the nearest inch. Okay, so we're rounding here. It doesn't say simplest radical form. What's the distance from home plate to second base? Okay, well that's easier than you think. The distance between every single base is 90 because, again, it's a square. So if you would draw a segment from second to home, that's the hypotenuse of your 45, 45, 90 triangle. If your legs are 90, then your hypotenuse is 90 square root of 2. That's the exact answer. But they didn't want the exact answer. They wanted it in to the nearest inch. Okay, so I'm just going to type into the calculator 90 square root of 2. And this is in feet. So that's an issue too. You want your decimal answers to the nearest inch. My goodness. All right, so this is, if I would round to the nearest foot, it'd be 127 feet. But the question is, 0.27, you could round that to 0.28 feet. That's really close to 0.25 feet. So if you have 0.25, that's a quarter of a foot. What is a quarter of a foot? The nearest quarter of a foot. How many inches? So a quarter of a foot is 3 inches. So calculating this answer wasn't bad, but then rounding to the nearest inch, oh, then that's a little bit more involved. It's 127 feet, 3 inches. Maybe it's better just to make it straight inches instead of feet. Okay, so if there's 12 inches in a foot, if you would just multiply by 12, this is your distance in just inches. Okay, so I'm going to call that 1527 inches because that's the nearest inch. What's the distance from third to first? It's going to be the same thing. It's another 45, 45, 90 triangle made from a square. The pitcher's mound is 60 feet 6 inches from home plate. Is it the midpoint of the diagonal from home plate to second base? If not, what's the midpoint? So if you put these two diagonals in, they're asking you, is that where the pitcher's mound lives? Right? Well, if it was the pitcher's mound, then it would be half of this. Half of this would be 45 square roots of 2. And that would be 63 feet. And a little more than half of a foot. This isn't 63 feet 6 inches, just so you know. It's 63 feet and 64 hundredths of another foot. So that equates to more than 6 inches, just so you're aware. So this is definitely not the midpoint. If not, what is the midpoint? Well, this is it. This is the midpoint. It would be 63.64 feet. And it doesn't say how to write the midpoint. I'm not writing it in feet and inches. I'm just writing it in feet. That's where that midpoint would live from home plate to second base.